Welcome back, students. You are now geometry students. Yay! Okay, so it is Saturday that I'm doing this. It's the Feast of St. Padre Pio, and I cannot resist the urge to share at least one quote for you because he is so amazing. Okay, he says, if we earnestly endeavor to love Jesus, this alone will drive all fear from our hearts, and so we'll find that instead of walking in the Lord's paths, it is flying. That's how our soul will feel. So let's today earnestly endeavor to love Jesus. And as you're going through this video and working hard, remember you can always offer everything up. Although I know it is not much of a sacrifice because these videos are very entertaining. I get that. But for those of you that maybe find it's not quite as entertaining as you would like, because for whatever reason, you can offer that up. Literally put the initials of a person on your review and decide that your ability to sit there and work hard and really try to learn and offer this time up for God can be used to better some other situation. So I encourage you to do that if you're not looking forward to the video, which I don't know why you wouldn't, but okay, let's get going. So we are now doing geometry, and unfortunately I did leave some of my things at school, which is really bothersome to me because I like to work with the figures and the different things I have, but I'll do my best. So draw a net for the figure shown, label the net with its dimensions. Okay, so a net for a prism, it's also a box. This is a right prism, but it's also a box. Always involves rectangles, and it's as many rectangles as are on the face. So we got a face here of 5 by 7, 5 inches by 7 inches. Okay, and it's going to come down into all those rectangles. Here's one rectangle. Then we can put the other face down here. So 5 inches by 7 inches. And then this part is the 9 inches. So I still have a total of 4 sides here. So I need to get those out. And this will be a little bit smaller. And then we got the bigger one. And then we have the smaller one. And this is 7 inches, so that means this is 5 inches right here. So that means this is also 5 inches right here. And then this is 7 inches, and this is 5 inches. So that's plenty. All right, the next one. What three-dimensional figure matches this net? So again, we got the 4 rectangles, and we got the top and bottom. They're all the same. So that is definitely a prism. This is a prism. That's a cylinder, so it's not going to be that because of the circles. But the bases here are triangles, so it's not going to be that one. So it's going to be one of these two, and in fact it's going to be this one because this has a rectangular side to it, and these are all squares. So it is indeed B. Oops, and I wasn't even pointing to it, but sorry about that. Make an orthographic drawing. Sorry, I'm holed up in the kids' room right now because they're putting, my son and my husband are putting in speakers in the ceilings in the kitchen and living room, and let's just say I was ousted and sent to my room, or my children's room. So the front of this, that's kind of tricky, but it's gonna, this, even though it's angled right here, if you looked at it straight from the front, you're gonna have a straight side right there. It's going to come down, but then see this line right here? That's going straight across, and then it comes down, and then it goes across, and then it comes down, and then it goes across. Now the only, when I look at this whole part right here, which is the front, the only line I see is this one is marked, so I mark that one. The rest of them I don't mark. I just label that as my front view. The right view now is viewing it from here. So again, this is all straight up and down on that side over there. Okay, and it's going across the top, But then it does angle right here. So it's going to angle down. And then I'm viewing it from here. So then we're going straight down again, the side. And across the bottom. So I'm looking to see what lines are over here. And I see there's a line right here. And then there's this line right here. And then there's this line coming across here. Did I get them all? 1, 2, 3. Actually, I missed one, didn't I? There's one here. There's 4 of them. And that's the right side. Although, no. Hang on. Back it up. All right. If we're looking at it from the right side, we're going to see this part, but we're not going to see this back one. That's going to be blocked from the view. And then we're going to see this one. I guess it's this one right here. But we're not going to see this right here. Okay, so we're going to see this, and we're going to see this. So I should balance that a little better. That is a pretty bad drawing, I must say so myself. I do have lots of mercy. Okay, there we go. Let me just look so I can reassure you. Are you making one of these on the test? Okay, actually, I give you the view. Wait, do I give you the view? Oh my goodness. Okay, enough, there's one on there. Okay, well, don't be too panicked by this. The top view then would be something that looks like a cross. Sorry, that is not supposed to be angled. Because you're looking straight down, so you're seeing this little thing here. You're also seeing this rectangle right here. And then you're seeing strip and strip. Those are the only 3 things you see. Okay, that was really hard. So don't, I mean, I hope you got it, but don't panic if you did not get that. I will stress the things that are most important here as we go through, and I'll just honestly say that was whatever, a bad one to put in here. How many cubes would you use to make the structure below? So you have to be super careful that you're counting all of them that are in there. So there's 1, 2, and then 1, 2, 3, 4, and then 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, and then there's 1, 2, 3 on the outside. So let me count them. I should have been counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, back 11, 12, 13, 14, and then 15 and 16 and 17. So you should have gotten 17, because remember, you're counting the ones that are in the back. You're assuming this is all going straight down in the back. All right, make an isometric drawing, which is difficult because there's no grid here for me to use, and unfortunately I didn't bring that with me. So I'm going to show you my drawing instead, which I have on my answer key here. So the way you want to do these is pick a starting point. So for example, if you pick this one right here, and you pick this one right here, just literally count up. It's like, okay, angle 1, 2, 3, and I do that. 1, 2, 3. And then even from there, we're here now, we can say, okay, I'm going to go up 1. Okay, I'm going to go up 1. And now I'm going to go back 3. 1, 2, 3. And I'm going to go down. And I'm back to my starting point. Okay, now I'm going to angle up to the left. And then I'm going to go up. And then I'm going to go 1, 2, 3. So you're working yourself around it. And you're like, okay, I got that part good. Okay, now I'm going to start up in this upper right-hand corner. And you start moving from there. And you're like, okay, straight up. Okay, now I'm going to go straight across. Okay, now I'm going to go 3. 1, 2, 3. I'm going to go down 1. I'm going to angle 1. I'm going to go down 1. I'm going to angle 1. And you work yourself around the whole picture. This is much easier to help you with literally individually. So before school or during lunch, I can help you if you're having trouble with any of the drawing things. It's a little more difficult to show you this page. All right, let's go to the other side. construct this, construct GH, okay, so we're making a new picture, such that PQ, remember this is a distance. When you see two capital letters, it's a distance from P to Q. That the distance from P to Q plus the distance from R to S is equal to the distance from this new G to H. Okay, so you're going to grab your straight edge and you're going to draw a line. I'm not making it any certain length, but I'm going to label one side of it G. And I'm going to grab my compass because it does say construct. Construct means compass and straight edge, okay, which is the side of a ruler. So we're going to take our compass and we're going to open it up as far as PQ, right there. Then I'm going to take it literally and go to my G and make a small arc. Okay, so right now I've got the distance from basically from P to Q right here. But I want to add to it RS. So now I'm going to go measure my R to my S. And I'm just going to add that on. So I'm going to go to the end of where I left off. And voila. Because this is the distance from R to S. That is my H. Now is GH equal to PQ plus RS? It sure is. Problem over. Construct WX. This is a what? This is a ray. The bisector of angle W. Bisector splits angle into two congruent angles. Okay, so you should picture where is it going to go? It's going to be going through here somewhere. Okay, so first step of these is to make an arc. Remember I said the best part to do is to angle your thing. Don't go straight up. Angle it. Open it up a little bit and angle it, and then turn your paper, and I don't even move it. Okay, I didn't move my compass at all. I moved the paper. Now you're going to use those two new spots, the two intersection points right here, and you're going to make two more arcs. Okay, so I'm going to put the non-writing edge again. It's like a pencil, really. You're holding the non-writing edge, and you're going to make an arc inside of that. So here we go. I'm going to lift this up and move it right here, and I'm going to make another arc right like that. Now that intersection point of those two arcs is one point that I need to connect with the end point, the W. So grab your straight edge, start with your W and your point, and there you have it. Construct WX. So I want to label it W, and this is X. Make sure you go back and just make sure you label everything as it's supposed to be labeled. Now we're going to construct perpendicular bisector of the segment. So remember, construct means compass and straight edge, and perpendicular means what? 90 degrees. And bisector we talked about. Up here we talked about how a bisector splits this angle in half. Well, it's the same with a segment. A bisector will split the segment in half. So it goes right through the middle. But it also has to be perpendicular. So I don't want it going through like this. I want it going perfectly through like this. Well, I can't just go draw it. I have to construct it. I have to see your arcs. So you just put the non-writing edge on one of the points. You make sure you are more than halfway to the other side. It's actually easier if you don't go all the way. And now I'm not starting at the line. I'm starting over here. And I'm making an arc so that half of it is on one side and half of it is on the other. I lift this up. I'm going to turn my whole paper because I want to make it easier. And I go to the other point. I don't go to where it hit. Okay? And I put my compass down and I turn my paper. Ah, does that look beautiful or what? Serious business here. I don't know. Connect them. Let's say a segment perpendicular bisector. Okay, so we're just going to draw a line. It goes right through it. Now it won't, like sometimes it can be off just a hinge and not look perfect, but I can tell if you did the construction perfect by looking at the arcs. You can also go in here and put your 90 degrees in there, because that means it's perpendicular. And how do we imply that it's a bisector and that these two parts are the same? Just put one arc here and one line on each side of that purple line. Don't have to do that, but it's just a good added touch. All right, now construct an angle so that angle B is congruent to angle A. Construct angle B so that angle B is congruent to angle A. This is angle A. Can't really tell, but it is. So I basically am copying and making a new angle right here. Okay. Not 100% sure we did this one. I can't remember. But it's similar. Actually, I think we might have. So we're going to start with our straight line. Just a generic straight line of some sort. And you're going to make this little dot and make that your arrow to replicate this side. Okay. Remember, these rays go forever, so the length of those rays does not matter. What matters is the angle right here. That's what has to be the same. So don't get caught up in how long is this and did I measure this. No, that goes forever. So right now you're going to take your compass again, because we're constructing, and we're going to make two arcs. We're going to go on here and make a small arc right on this picture such that it hits both rays. Okay. Then you're going to go over to this one and you're going to make an arc kind of in the same spot that this other one was. So I want to start back here a bit. Okay. And I want to go all the way through. I'm trying to replicate exactly what I see on the other one. Do you see that? Now the only thing I need to do is I need to know where this line is going to go through. So the way we're going to do that is we're going to measure this arc. So we're going to open this up to the distance of between these 2 points. So you drew an arc such that it hit that in both points. Well, you have one of those points right here, and we need to go over here now and see how wide that is. So we're going to open this up like that. And I'm literally going to just lift it up and slide it over here and make it a little arc right there. Okay, that is the same distance as that. So yay, I have my other point and I have this point, so I have all I need now to make the other ray. Again, the distance of the ray is irrelevant. What matters is this angle the same as this? Yes. What was it labeled? A B. So I go in and put B. All right, the next one. Are points C, G, and H collinear or non-collinear? So I highly recommend that you literally take your highlighter and go in and highlight the C, highlight the G, highlight the H. Okay, if it's collinear, remember what word is in there? Line. That means that these 3 points, if it's co, that means they're on the same line. Non means they're not on the same line. So, can you take, let's just say, one toothpick and lay it such that it hits the C, the G, and the H all at the same time? If you can, I'd love to see it, because that'd be quite the magic trick, because there's no way you can lay it and hit all 3 at the same time unless it's one massive toothpick. Okay, so that's non-collinear. Wait, let me ask you a different question. Are C, G, and H coplanar? Now that means they are all on the same plane. And the answer to determine that is not the toothpick, because that toothpick is a line. You're thinking of a piece of paper. Can I take a piece of paper, a nice flat cardboard piece of paper? How is a piece of paper cardboard? But anyway, How about a piece of cardboard so it's a little stiffer? And can you lay it and touch those 3 points with one flat piece of cardboard? And the answer is yes. So those points are coplanar, but they are not collinear. Okay? Sorry, I'm still back on this. Are G, H, A, and E collinear? No way. Are G, H, A, and B coplanar? Yes. You could put a cardboard piece right through the middle of that, and it would lie on all 4 points. Okay. All right, next. What plane, oh, here we go with plane. What plane contains points C, D, and G? So here's C, here's D, and here's G. So which flat piece of cardboard would cover all 3 of those? And I'm going to say this one right here. C, D, H, G, that side. So let's see which one describes that. The plane at the bottom of the figure. No, that would be E, F, H, G. The plane at the top of the figure. No, that's A, B, D, C. The plane at the front of the figure. Yes, that is C, D, H, G. What does the other one say? I should put this up here. I kind of like that when you write them on the blanks. The plane that passes at a slant through the figure. Nope, that would be A, C, H, F, or B, D, G, E. Well, actually, there's 2 more. C, D, F, E, or A, B, H, G. Okay. Name a ray in the figure. Okay. All right, that should be an easy point, people. Rays always use that symbol. And the endpoint is always listed first. So this is my endpoint, A. And B is just any other point on the line, or on the ray. So where is that? Right here. D. That's a segment, people. That is a segment. That is a line with both arrows. Line. This is a line segment. This is also a ray, but look what the endpoint says. B. It's not B. All right. What is the intersection? Okay, so when they say intersection, they're saying the overlap of plane S, T, X, Y. Okay, I'm going to look at where that is here. I'm going to actually use a pencil. S, T, X, W, okay. And plane S, V, U, T. So where's S, V, U, T? Okay, that's at the top here. So we're not, you got to remember, this is 3-dimensional. So it's not all that stuff that you see in pencil and purple that overlap. You have to imagine, we got the top of the cube, and we got the side, not the cube, the box. And the side of the box, where are they touching? And the answer would be from here to here. That side right there. So, and you might say, wait a minute, that's segment ST. Okay, on that picture, it certainly is segment ST, but we have to be careful because the question said the plane. So remember plane? Even though we're looking at just this part of that plane, the plane goes forever in all directions, and that plane goes forever in all directions. So the part that overlaps is really a line, because that also would go in all directions. So is there an ST? Yes, and that's why there's a line above it, just to be clear, and not a segment bar. Okay. Complete the statement. G, D, F is congruent. Remember, this is congruent. Figures are congruent, and numbers are equal. Our equations are equal. And measures are equal. So we got to do it the same direction. So when we do G, D, F, notice it's the double to the 1 to the 3. So when I'm over on this triangle, I got to do that same thing. It's E, D, F. What are the names of the three planes that contain point A? Okay, well, let's just see. We got the back plane, the one that we used pencil on the one up there. I think it's kind of, is that the same picture? It looks pretty similar. Okay, we got that plane. So when you label a plane, you just go around. So A, B, F, E. That's one. And then we also have the top part. So we have this part up here. So what is that? A, B, D, C. And then we have the side part that touches A. Which plane is that? A, C, E, G. Oh, I did it wrong, didn't I? A, C, E, G. I can't jump across. A, C, G, E. So let's see, let's find the right one now. A, B, D, C. A, B, F, E. A, C, no, that's not it. Okay, those are the same. No. Okay. Where is A, C, G, E? Where is A, C, G, E? Oh, okay. Darn, I wasn't paying attention. Okay. Let's just start here. A, B, D, C. Yes, that's right here. A, B, F, E. Yes, that's right here. Okay. A, C, H, F. Where's that? A, C, H, F. Okay. It's this cross one right here. And that is the answer. Sorry about that. I guess the better plan, instead of just looking at those three, because there is the diagonal one as well, that could be an option. So that's good that that came up so we don't forget about it. You have the top, the side, the back, and the diagonal one. They didn't include the side one though. Okay. Oops. Each unit on the map represents 5 miles. I'm going to highlight that because I know I'll forget that later, because I'm going to forget and just do it wrong. And you should always highlight those things, because when one little spot represents something bigger, when you go about to make your bigger mileage, you might forget that when you're figuring, after you figure it out. What's the actual distance from ocean front to seaside? Okay, so we need to go from ocean front to seaside. So we're looking for that. So what is this coordinate here? This is -2, 4. And this one is what? 3, -2. Okay. It's not a straight line, so we need to use our distance formula. So let's see here. Square root of, subtract your x's, -2 minus 3 squared, plus subtract your y's, 4 minus a -2. Don't lose your negatives, people. -2 minus 3. Hang on a second. Andrew, be quiet. Sorry about that. All right, so -2 minus 3 is a -5 squared, plus 4 minus -2 is a 6 squared. And then -5 squared is 25. 6 squared is 36. We get the square root of 61. And keep in mind, when you square these and you get to these, they should never be negative. When you square a number, whether it's negative or positive, look what happens, right? You always get positive. So if you're getting a negative in here, you're missing that. All right, so let's see what that is. It says about, so we need to use our calculator for that one. And we need to do 61 square root 7.8. And if you didn't highlight this, you might be circling 8 right now and you'd be 100% wrong. Okay? it says each unit represents 5 miles, so I have to multiply that by 5. And I get 39. So it's about 40 miles. Okay? So be very, very careful. All right, D. All right, next one. Complement. Remember what a complement is? Complementary angles are two angles that add up to equal 90. There's shorthand. So the complement of an angle is 53. What's the measure of the angle? So we're trying to figure out what the other angle is. So 90 minus 53 is 37. The perimeter of the parallelogram, find the perimeter of the parallelogram with these vertices. So A is negative 5, 6, and B is 2, 6, and D is 8, negative 2, and C is 1, negative 2. I'm going to make sure those make sense so I didn't make a mistake. Good. Okay. And we need to get the sides. The good news is this is horizontal, so I can just count. So I'm counting from a negative 5, right, all the way over to a positive 2. So how far does that? 7. It is a parallelogram, and in a parallelogram, opposite sides are congruent. So if you can go and count it out, but you're going to find it's the same. It's a 7. And that also is the same with these. So again, you can use the distance formula, which is what we're going to have to do on both of them. But if you remember that the opposite sides of a parallelogram are the same, then you can use that. So I'm going to figure out what BD is. Remember, 2 capital letters mean the distance from B to D. That means use that distance formula. Subtract your x's. 2 minus 8 squared plus subtract your y's. 6 minus a negative 2 squared. Negative 6, 8, 36 plus 64. I love it when they turn out so lovely, which is 10. Now that's not my answer, right? That's just this side, and then I know this side is the same. If you don't know, then just do it. You'll see that it is. 10 plus 10 is 20, plus 14 is 34. Describe a real-life example of 2 planes and their intersection. Okay, it can be very simple. Just think of the classroom. We talked about this, and we talked about the wall that the smartboard is on and the floor. Wall and floor. And what is the intersection of those two? And we said it was the corner, right? In the corner, the wall and the floor represent the planes. And what does the corner represent of those two? A line. That would be the intersection. I wrote that wrong on there for some reason. Okay, find the nearest tenth, highlighting so I don't forget. The area of a region. The area of the region that is inside the square and outside the circle. The circle has a diameter of 6. Okay, the circle has a diameter of 6. So this is 3 and this is 3 then. And this is 3 and this is 3. If it's a circle. The area of the region that's inside the square but outside the circle. So that would be this part right here. Trying to find that area. Obviously we don't have formulas for those weird shapes, but I can get the area of the square, right, this whole big thing, and if I take away the area of the circle out of it, I'm left with those weird shapes. So the area of the square is s to the second power. Well, each side is how long? Same as this, 6 and 6. So that's 36. The area of the circle, which is pi r squared, What's the radius? 3. So pi times 3 squared. So I have 36 minus 9 pi. So be careful here because you need to be careful with parentheses. Some calculators you do and some you don't. But when I do 36 and I do minus, because this is a multiplication, I got to do that together. So I'm going to put a parenthesis and do 9 times the pi button, and then do the right parenthesis, and then equal. It should be 7.7. Let's see, is that one of our answers? Yeah. Okay, because this has a multiplication in here, so you have to put parentheses around that, so that it does. Otherwise, what it's going to do is do 36 minus 9, and then multiply it by pi, which is wrong. But again, some calculators, if you just put 9 pi symbol, it might do it. You have to see. You can check with your calculator right now and see if you get the right answer. Find the circumference of the circle to the nearest tenth. Now here it says use 3.14 for pi, so we will do that. Circumference equals 2 pi r. Circumference equals 2 pi times 25. Circumference is 50 pi. 50. And I had said to use a 3.14, so I will. 157. Next, find the area. Circle, nearest tenth. Use that. Can't remember if I did that for the test. Let me look. I can't remember. I have it right here. You know, I say terms of pi, actually. So on this one, instead of this, I'm just going to practice with you. Write in terms of pi so that you're not confused by that when the test comes. So area is pi r squared. And the radius here, that's the diameter because it's right in the middle. So I got to divide that by 2. So we're going to do 9.7. Divided by 2 is 4.85. And so I'm going to give pi times 4.85 to the second power. I will take the 4.85 and I will square it and get that 23.5225. I would actually write it all out because it doesn't go off the calculator. So since it ends, I'm just going to write that. And then here, I didn't do the pi yet. So when it says in terms of pi, you just leave it like that. And it is inches, so I will put inches squared. But that's how you would write that answer. Now, to see if you did it right, they said to use pi. So let's do 4.85 squared times 3.14. And your answer should have been 70, round to the nearest tenth, 73.9. Complete the statement. Drawing is not to scale. If GDF, so you got to find GDF. Remember, that's the vertex, D. GDF. So this angle right here is 54. Then measure of angle EDF. EDF right here is what? What do you think? Yeah, it's the same. Why is it the same? Because of the arcs. Exactly. Very good. So that didn't even take any calculation. When you see one arc and a 2 arc, the same. 54 and 54. So together, 108. Okay, the next one, if T is the midpoint of SU. Okay, so what does midpoint mean? It means it splits into 2 congruent segments. Okay, so it means this is equal to this. Okay, so what are ST, TU, and SU? And that's distances. What's the distance from S to T, from T to U, and the whole thing? Well, if I get both, I can just add them, right? So the truth, though, is I don't have any numbers here, but I know this segment is equal to this segment. That's what midpoint means. So I can take the 9x equals 5x plus 8, and solve. So minus 5x. We have 4x equals 28. Divide by 4, and x is 7. So x is 7, but that's just x. And some of the problems on the test will say what is x as well. So you might need that for an answer. In this case, they don't ask that, but 9 times 7 is 63. And this should be 63 as well. I'm going to check. 5 times 7 plus 28. 35 plus 28 is 63. Good. It should be the same. So 63 and 63 are two of our segments. And then to get SU, we just would add those. So SU would be the 126. So let's find those. 63 is ST, TU is 63, and SU is 126. There we go. All right, M is 7.5. I'm sorry, M 7.5 is the midpoint of our S. Okay, the coordinates of S are this. What are the coordinates of R? So remember, when they give you the midpoint, set it up like this and put 1 on top, and you're looking for this bottom one. So you just follow the pattern down. 8 to 7, you subtracted 1. So you subtract another 1 and you get 6. 7 to 5, you subtracted 2. So subtract 2 again and you go to 3. 6, 3 is the answer. That's the easiest way. I used to try to explain a different way, and I'm telling you, that's much easier. All right, name a fourth point in the plane WXV. So where's W, X, and V? What do you think? How are we going to connect and put a piece of cardboard? And, well, it's going to have to go over that, and it's going to go over that. So where will the other one be? Right here. That it'll go right through the figure there, so U is your answer. If EOF is 26, EOF, that's 26 degrees, and FOG is 38. Okay, so it's definitely, OF is not a what? Definitely not a bisector, is it? Because if it was a bisector, these would be the same. All right, that's just a side point. Then, what is the measure of EOG? Oh dear, EOG, the big angle, would be 26 plus the 38, 64. Good. All right, down here, MO, this ray, bisects LMN. So that is a bisect, whereas this did not bisect it, this does. So that tells you this and this are the same angle measures. And they go in here to tell you that let's see here, LMN, whole big angle is 5x minus 22. I'm just going to put that on the top because that signifies this whole big angle here. LMO, this littler one is x plus 31. Find NMO. Well, we want to be able to set some things equal. And just like up here we said this angle plus this angle, we added them together to get the big angle, right? Well, if we had this angle, we could do the same thing. This plus this equals the whole. But we don't have that, or do we? Because of this information. Bisects. That means this and this are the same. So we do have this. It's x plus 31 as well. So now I can add those two angles and it should give me the whole big angle. And then I can solve and figure out what x is and plug it back in. So x plus 31 plus x plus 31 equals this big angle, 5x minus 22. So we just have to solve. So combine like terms over here, and we have x plus x is 2x, and 31 plus 31 is 62. And then we're going to solve. Move the smaller x, that makes it a little easier Keep things positive. Okay, move this over, get the x alone. And divide by 3. What is that? 28. Okay, so we get x is equal to 28. Okay, that doesn't answer the question because it said find the measure of angle NMO. So we need this one right here. Well, that one is x plus 31. So 28 plus the 31 is 59. Next one. Oh, I didn't even do my commercial break yet, and we're almost done, you guys. There's no backside. What? Okay. Guess it is 45 minutes. I'll skip the commercial break. All right, if EF equals 4x plus 15, and FG is 39, and EG, the whole thing, is 110, find the value of x. Well, this is your segment addition property. This segment plus this segment gives you the whole segment. So let's do some math. 4x plus 15 plus the 39 is equal to 110. All right, like terms, 39 and 15 is 54. Subtract the 54. What is that? 56. Divide by 4. And x is 14. Last but not least, and then I just want to look real quick and make sure I covered everything for the test. If a perimeter of a square is 140, what's its area? Well, you got to work backwards to work forwards. They've given you perimeter and you need area. Well, area of a square is s squared. So I can't figure out the area until I know the side. Well, I have the perimeter. Perimeter of a square is 4s, right? So if I'm given the perimeter, how do I go back to a side? Divide by 4. You don't have to show that work. I actually just want you to be able to, what is that? 4 into 140. 35. So S is 35. So remember, if you're given the perimeter of a square, just divide by 4 to go backwards and square it to go forward. So 35 squared. What is 35 squared? 1225. We're done. Okay, I'm just going to flip this over. I'm going to do a quick scan. I actually have the test here. I just want to make sure everything is covered here. Oh, I know. We did a net for a any kind of a prism would be the rectangles. Like, let's just say it was an octagon. Be 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Yep, and then the top would be a whatever. I'm just doing it really fast. An 8-sided figure. That's the net for a octagonal prism. But what if it was an octagonal pyramid? Well, then you just have the one octagon. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I hate octagons. Let's do a pentagon. I won't have you do an octagon, I promise. If I was doing a pyramid, remember the sides aren't rectangles anymore. They are triangles. So that's the easiest way to do a net. For pyramid, that's a net for a prism. Okay, got to know how to construct a segment, construct the bisector, construct the perpendicular bisector, construct the angle. Those are all in there. Know what collinear is, know what coplanar is. If I give you a line, C, D, E, F, G, and I told you ray F, D. Can you tell me the ray that's opposite of FD? So the ray FD is right there, right? D is just on the line. I could have said FE. I could have said FC. Those are all the same ray, right? FE, FC, all the same. The opposite ray is the one that has the same endpoint, F, but goes the other way. So the only answer for that would have been FG. That's your answer. All right. Oh, I didn't tell. Yeah, this didn't hit vertical angles. Remember vertical angles? If we have all these intersecting points, lines, I mean, what are the vertical angles? The vertical angles are the ones directly across from each other. Those are vertical. And those are vertical. And those are vertical. And yes, they are always equal measure. One's 30. This is 30. This is 30. I don't think we actually talked about that, but it's true. Name an angle adjacent. Okay, so what angle, let's say we have another figure like that. I'm just going to draw it there again. What angle is adjacent to this angle? Just kind of envision it. You should have told me either this one or this one. Well, actually, it could be these bigger ones too. As long as the side is in common. Remember, adjacent angles are two angles that share a ray. So these two, they're like neighbors, right? They have the same endpoints, the angles, same endpoints, and they share a ray. Where these other two are doesn't matter. Maybe this is bigger than this. That's fine. Doesn't matter. Okay. What about if I said which one's supplementary to this purple one? So we have this purple one here. Which one's supplementary to that? Remember, supplementary has to form a straight line. So this one right here would be an answer. That's supplementary. Or you could have said this one right here. That angle is also supplementary to that angle right there. Okay, remember supplementary is 180, complementary is 90. You can tell by a figure if you have a right angle, right? If I have a right angle like that, I know for a fact that this angle right here and this angle right here are what? Complementary, because I see the 90 degrees there. And that would be the same for these two. But okay. I also wanted to ask you, I'm getting tired. What about if I give you a figure like this? And I tell you that this is 120 degrees. Could you figure out the other measures on that figure? Okay, I hope so, because you should see that this right here forms a what? Linear pair. Remember, a linear pair means two angles, right? That's a pair. And linear means it forms a line. So I've got two angles that form a line. So they are supplementary. 120, that means this would have to be 60. And look what you have here. Another linear pair. So this has to add up to 180. Or you could have noticed the vertical angles. And again, we have another linear pair. So this has to. So you can figure out all of those on that one. So remember, a linear pair, it's two angles that make a straight line. So that tells you they're 180 degrees. All right, let me look through here. Remember that the only information you can assume by a picture are little right angles, right? You can also assume markings. So if I go like that, oops, you can assume those two sides are the same, right? You can also assume that these are vertical angles, because you can tell because they're right across from each other. A vertical angle is any x that you find, they're right across from each other. Okay. All right. Still looking. Midpoint. What does midpoint mean again? In the middle. So this equals this. So you can always set up an equation with that if you need to. One plus the other one equals the whole as well. This plus this can also equal the whole. Alright, I think we're pretty good here. I'm looking on the last page, make sure I didn't miss anything. Okay, what if I tell you you have a linear pair, and let's say angle 1 and angle 2 are linear pairs, and let's just, I'm totally making this up, but what if I said measure of angle 1 is x plus 10 and measure of angle 2 is x minus 2? What would you do if I said find x? Or if I said find the measure of each angle? Well, linear pair means two angles that make a line, so that means they add up to 180. So I can take this plus this and set it equal to 180. So like terms 2x, I don't know if this is going to work out, equals 180, subtract 8, 2x equals 172. X is, what is that? 86. Okay, so x is 86. So this angle would be 96 and this angle would be 84. There's my answers. Okay? So you can always use that information to set up an equation. Same with complementary angles. If I tell you two angles, instead of saying it was a linear pair, if I would have said those two angles are complementary, instead of setting them equal to 180, what would I have done? I would have added them up and set it equal to complementary 90 and solved. All right. The last thing I'm going to say, running out of room here, is what if I tell you you have a bisector? Actually, you don't have a bisector. I lied. You just have some figure. And I'm just going to say that this is angle is 2x plus 1 and this is x plus 3. And I tell you that this whole angle here is 60 degrees. How would you figure out what those angle measures were? Well, first of all, I mean, I may give it to you in a picture. I may just tell you the information. You have to put it on the picture. But angle addition property. That angle plus the other angle equals 60. And solve. I wonder if this will work out. I don't know. Probably not nice. Nope. 18.6 repeating. And then you'd have to put it back in here. So 21.6 repeating. And then multiply by 2 and add 1 to get those two. Obviously, whenever I make them up, it never works. So that should be it. You study that, you should be all set to go. All right? Just make sure you can do all those different constructions as well. All right, sorry this got so long today, an entire hour. Yikes, you guys are going to go nuts, but it's all so good. All right, take care. God bless. Bye-bye.